All right, let's move on to our next talk. Andre Wong will talk about the Arizona Infrared Detector Laboratory.
Hi, everyone. My name is Andre Wong. I'm a system engineer over at Stewart Observatory. So I'll be talking about the new infrared detector lab that we've been working on setting up. So this lab that we're setting up, we're really committed to enabling and enhancing kind of all the science associated that can be done in the infrared, both in terms of detector development and also instrument development and deployment. What we want to do is leverage all the great work that Arizona has been doing in the infrared. You heard Walt talk about all the great observatories that we've been contributing to, JWST, Hubble, and Spitzer. We want to make sure that the heritage that Arizona has built in the infrared continues into the future. So we have kind of three pillars that we want to focus on to do that. So first is to prepare. We've heard a lot from Kim and Walt about making sure that we train the next generation of engineers and scientists. So we want to continue to do that in the infrared. We want to make sure that we understand the science and the technology in the infrared to make sure that we can actually build the instruments and continue the work that JWST and all these other big observatories have been doing. So we want to make sure that we study and we delve deeply into how these detectors work and also the technology that goes behind them, and also looking forward to future technologies that may appear in the future. And then finally, we want to take all this information on the people that we've trained and build instruments that support all the science that all the researchers and professors here want to do. So what we do, we want advanced infrared detector technology. That's either by taking newly emerging technologies and trying to develop them into high TRL applications, taking existing technologies and converting them and understanding their use in different science cases, and also taking even commercial off-the-shelf technologies and then understanding how we can use those for science. We want to take these detectors and see how we can use them for the different science that people want to do. So basically use them in new ways or even old ways. We want to eventually build and deliver infrared instruments. And then all this depends on being able to partner with a range of scientists here at UA. So while we're part of the astronomy department, we're also interested and excited to serve scientists and researchers here that work in earth science, planetary science, basically whatever, even biology. I know there's a lot of work that's being done there in the infrared. And then finally, as I mentioned, we want to make sure we train and mentor early career engineers and scientists and make sure that we have the next generation of these engineers and scientists to continue the work even after I retire and the people after me retire. So currently, we have three main founders. Jared, which you just heard from, who also heads the infrared detector lab. He was, as he mentioned, a member of the NIRCam team. He's very interested in this detector technology and also science, mainly high contrast imaging related to the use of these infrared detectors. Brittany Miles is currently a postdoc of 51 PEG-B and a presidential fellow here at UA. She just accepted a assistant professorship at Stewart. So she's part of the Scales instrument team and also JWST, and she's also interested in instrument development in the infrared, as well as characterization of planetary atmospheres. These are exoplanets outside of our solar system. And finally, myself, I'm an engineer here. I have a lot of experience in detector and camera engineering. So my main interest is just basically implementing instruments and detectors in the infrared, primarily for space-based missions. So our key facilities. So last year, we gave a talk about AIRD. That was kind of our coming up party. We were just getting started, but we're starting to get some momentum here. So we've acquired about 60% of the 10th floor lab in Gold Simpson. So this is an ISO 7 class 10,000 clean room. So we have about 1,200 square feet of space so that we can utilize for the work that we want to do. And attached to that is also about 700 square feet of electronics lab space. So this non-clean room space, but we can use it for supporting electronics and detector work. We also currently have two cryostats on order. So these are cryostats which we intend on using to help us characterize these detectors. So both of them are capable of supporting detector temperatures of less than 40 Kelvin. We're expecting them in certain situations to be able to run down to 25 Kelvin if needed. These doers have ultra low backgrounds in the long wave infrared, which is really, really important for space-based astronomy observations. They also have motorized filter wheels and shutters, high-speed shutters to support the testing that we want to do. And we expect them to provide greater than 95% uniform illumination over an 1,100 millimeter square area. So that's really large. That's about 3 inches on the side. So we have two of these on order. We also have the old JWST metrology crossset that's been transferred to our cognizant. So we're working to get that up and running so we can use that for future work. Jaren being part of the imaging technology lab, myself, I'm also the deputy director and chief engineer. We can also leverage that capability with ITL to do the to support any infrared work that folks at UA might want. So how can we help? We want to be a service to the researchers here. So what we want to do is provide all sorts, basically a full set of support for maturing projects. Starting conceptual stage, if you have something an idea that you want to do, we can help you with detector selection and design of instruments, to submission of proposals. And then finally, once we win those proposals, we'll be able to help you build, test, and deliver this hardware. So what we can provide is basically deep understanding of infrared detectors. We can help you select detectors based on performance needs, cost needs, whatever dimension requirements you have for your mission. We can help you identify new technologies and design to pursue, and then how we can help you increase the TRL of the detectors, so we can make sure you can propose those successfully. And then basically, again, once you've won that proposal, we'll help you develop it, build, and more importantly, help you characterize and calibrate those detectors and instruments. So I showing this picture again. This is actually my favorite picture from the JWST first light images. So this is the Carina Nebula. So I show this just to remind everyone, this is the work that Arizona has done. This is from the NIRCam instrument. I want to make sure that we continue to make pictures like this and also the science that goes behind it. So any questions? Nope. Right. Thank you.